And another thing you're going to see that I do in class is I like to use different colors and highlighters and stuff like that. So if you have different colored pens, you might want to bring them sometimes because, for example, on this graph, I'm going to put 4 different graphs on here. And if you're just using a pencil, they're all going to look like you just scribbled all over this graph in the end. If you use 4 different colors, it's going to make your brain connect to things quicker when you look at it again. So for example, I'm going to start with blue. And if q is 3 and I have x squared plus q, I can write that that would be x squared plus 3. And if we think back to grade 11 math, and this is why this is in the getting started section, in grade 11, you had the equation of a parabola like this, where P and Q represented finding your vertex. So if you were asked to graph this using the math you learned in grade 11, you would say, oh, there's nothing other than the x being squared, so then my P is 0 and my Q is 3, so my vertex is at 0, 3, and I would know that point. Then a standard parabola goes over 1, up 1, so you'd be like, I also know those 2 points. And then it would go over 1, up 3, so you'd have 2 more points up there, and you'd be able to draw your parabola. Now in grade 12, and what we did on those 4 colored papers, was we started recognizing pattern when things moved left, when things moved right, when it moved up, when it moved down. Okay? And we started using the language of, is a number inside the function or outside of the function? So our starting function, x squared right here, we would say that this plus 3, it happens after. We're going to say it's outside of the function. That 3 is not getting squared. Anything that's outside moves it up and down. And did this graph look like it got shifted up 3 units? Absolutely. So we look at the second one, and here's where I would say, if you have a different color, I wrote the first equation in blue. Then if you look at this later, your brain is going to see blue writing, blue graph, and be like, the connection is really quite easy to see which one is which. And here we have a minus 3 outside. If you used grade 11 math, your vertex would be at 0, negative 3. Over 1, up 1. Over 1, up 3. Over 1. Using the ideas we've learned in grade 12, this is just taking the original graph and shifting it down 3 units. Purple. Y equals, now it's inside. So if it's a negative 3 and it's minus 8 minus negative would be plus. And here the 3 is inside what's getting squared, so we'll call this inside. Anything inside affects something horizontally. Horizontally is with the x. X's are liars. So instead of moving 3 to the right, this would move 3 to the left. If you think about your vertex, you learned last year that in the vertex, this was always the opposite sign and Q was the same, which would do the same effect. This graph is the original graph, moved 3 to the left. Finally, this minus 4 is inside. Using last year's vertex, your vertex would have been at 4, 0. So I find by using the colors, now I look at my equation, I immediately know which graph is connected to it. So if you're reviewing this or looking at this later, it would probably mean you can skim over it that much faster because of how things make connections and make sense. Now the next one is just too much. They give you all these graphs. They don't color code yours. Yours are all different shades of black and gray. So that's why we're going to skip that. But you can turn to the page 164. The textbook also will have some notes, and sometimes we'll highlight certain things in our notes from this. Here's our square root graph that we did already. So we have y equals square root of x plus 2. Do you see that that plus 2 is outside? Outside moves things vertically, so if I click on that, sure enough, it moves it up 2 units. If I had square root of x minus 1, it would move it down 1 unit. Okay? You are going to be asked to describe things in words. So this is where I would take out a highlighter. And just look at the proper way of describing how something is translated. These are moving up and down, so we'd use the word vertically. A vertical translation, 2 units up. A vertical translation, 1 unit down. Next, could you still do this question if the blue one had been written this way? Mm-hmm. Can you see this is another, or I'll write the green one too. Can you see that that's the same thing? What did I do?
You just moved the thing, the number on the outside of the equation. Is that the correct term?
Yeah, this is an equation because that is an equal sign.
On the outside of the equation to the other side.
I moved it to the other side. So having a minus 2 on this side, personally, I like this better, okay? But if you wrote this as the answer and you looked in your answer key and it was in this form, just to recognize that it's the same thing. And there's sort of 2 schools of thought on this. One school of thought is, you know how the x was always the opposite? Well, if we move the number to the other side, so it's with the y, then the y would be the opposite too. So some people like to just be like, always have the opposite. I personally like having y by itself, having the number on the other side, and just remembering the x's are liars. Here's one with x's, right? Here's a plus 2, it's going to move 2 to the left. And here's a minus 3, it's going to move 3 to the right. And if we highlight the words again, horizontal translation, 2 units to the left, horizontal translation, 3 units to the right. So that leads us to example 1. And I generally make 1 video for each example, but this one I'll put the introduction in with example 1. So now the textbook has example 1 written, and it has a solution. So anytime you want, you could read the textbook and read the solution to get an idea of how it works. The problem with a textbook solution is that they have to use more words and write more things than you actually have to show if you were doing the question yourself. And they have to do that because when we do a question together and we'll write down just what we need to write, we still add a lot verbally to help explain it. Okay? But a textbook doesn't have that advantage to say, this is all you need to write down without the verbal explanation because they have to write it. So what's going to happen is you can read examples on the side on your own, but we're going to do the question off to the side together. And notice there's space. That space is there for you to write all of the information down and work as we go through. Okay, once again, I'm going to do some color coding here. So I'm going to do everything for A in blue. So here's the graph of g of x. Sketch the image graph after each translation, write an equation, state domain and range. And I get to part A and it says, a translation of 4 units left. So take each of these points, go 1, 2, 3, 4, 4. Move each of them 4 units to the left, play, connect the dots, so much fun. There we go. There's our new graph. And at this point I'm going to talk about how reading in math is different than reading in English, is different than reading in a geography class or a history class. After you finish a question in math, you should always reread the question. This is a great example because I got super excited about knowing what I needed to do. I only did part of the question. You see that here's the graph of g of x, sketch the image graph after each translation. I did that sentence, but I didn't write the equation of the image. I didn't state the domain and range. I missed part of the question. So rereading helps us figure that out. The second sentence says, write the equation of the image graph in terms of the function g. So the next thing I want to highlight, because this language is very confusing for students, seems to be something that we're able to do if you see me do it, but then when you read the same question, you have to do it on your own, you get stuck. What does that mean again? Okay? In terms of the function g means that you are going to write an equation. First of all, if something says an equation, that means there's an equal sign in it, and there's something on both sides of the equal sign. And whenever something says in terms of, that has to be on the right-hand side of your equation somewhere. So in this case, I want to write an equation of this blue graph in terms of the function g. So I'm going to have an equal sign. On the left side, it's going to be y equals. On the right-hand side, this is going to have g somehow. I've moved it 4 to the left. Left and right is inside. X is our liar, so I'm going to have x plus 4. This would be the equation. I have g on the right-hand side, so it is in terms of g. And what they're saying is, I recognize that my new graph is just the old graph. The old graph moved 4 to the left. Question also asked for the domain and range. So again, what you didn't see me do, because you know how you can read without saying things out loud? I just reread the question again because I thought, oh, I finished something. More grade 10.
Sorry for the interruption. Any grade 9 or grade 10 student who did not get their picture taken, please go to the gymnasium now to do so. That's any grade 9 or grade 10 student who did not have their picture taken. You need to go and have that done, please. And any teacher who has a spare who did not get their picture taken, please also go and get it done. Thank you.
Domain, again, those are our x values. Our smallest x value is -5, and it includes all of the x values, and our biggest x value is 2. 2 ways that we could write the domain. In set notation, we would do this. X is in between, -5, and 2 includes everything in between. We have equal signs there because it includes the endpoints as well. Make sure this is connected. Or, in interval notation, we would have a square bracket going from -5 to 2. So at the beginning, I'll do both notations for a bit, just so that you can see both of them. Later on, I'll start choosing one or the other. If you are doing a question and it asks for domain and range, you have the choice. You can choose whichever form you like the best for writing the domain and range. Okay? Here's our range. Smallest y value is positive 2. Biggest y value is 5. And now I'm going to read the question. Here's a sketch. Sketch the image. We've sketched the image graph. Write the equation of the image. I did that. And state domain and range of each function. Well, I've done this domain and range of part A. I guess I'll have to do part B when I get done. So this is where reading and math is different. In English, you're going to get a novel. Have you got a novel already for your English class this year? Not yet? Okay. So you get Shakespeare. You get Macbeth. You finish reading it. Do you read it again? And then when you finish reading it, read it again? In math, we sometimes have to read, like this question I think I've read 4 times already, just checking to make sure I did everything. First difference between reading in math and reading in English. In math, you have less to read, but you have to read it more than once. Always good. Read the question, do the question. The last thing you should do when you're done the question is read the question again to make sure you answered everything. Okay? How many people have left something or missed something on a test? They're like, oh, I didn't read that. Okay, I'm in there too. Definitely. So it's a good strategy in math to read it again. Second major difference in reading is in math, every word might change the meaning of the question. Every word could be important. As opposed to sometimes if you're reading a textbook for geography, do you ever learn that strategy? If you just read the first sentence and the last sentence of a paragraph, you probably get the idea and can move on, and then you could read very quickly. Right? If you read the whole paragraph, you're probably not going to remember it anyways, so just the first and last sentence. Maybe you get the main idea, find out if you need to read more or less. You can't do that in math. Every word is important. Part B, switch colors again here in B. Now we're going 1 unit up. I sort of have in my memory what we need to do, so I know we need to graph it. There's 1 unit up. I know we need to write the equation in terms of g, and this time it's going to be outside the function, so we would take our regular graph g of x and add 1. And finally, we need to do the domain and the range. Smallest x value is -1. Biggest x value is 6. I'll just do one notation for this one. -1 to 6. And for the range, smallest y value is 3. Biggest y value is 6. And even though I've got the question memorized because I've read it 4 times, I would double check and read it again now that I finished the question. Did I answer everything in the second? When we finish a question, what I'm going to do is above the question, I get you to write it above. I will sometimes just write it wherever I have space, but I think in your book it makes sense. I'm going to write down the questions you can now do for homework. So since we did question 1, in your homework, you can now do questions 4, 5, 6, and 7. So not only are you going to write down 4, 5, 6, and 7 above, then I'm going to also get you to turn, because the homework questions are right after. It starts on page 169. And question 7 is on 170, so I would actually get you to circle 4, circle 5, circle 6, and circle 7. So later when you're looking, oh, which questions should I do from homework? They're already circled and you know which ones I've assigned. If you're like, get stuck on one, having the numbers here kind of reminds you this is the question that it's kind of similar to. Or, I was supposed to be able to do it based on what we did here. Maybe there's a hint in this question that I can look at that can help me understand. Okay? One thing that's really nice about this textbook is the answers for all the questions are not all the way at the end of the book, but they're right after the exercises. So the last question on the exercises ends on page 175. And if you turn to 176, all of the answers for the questions are there. So that's where you can be checking and seeing what went well. Okay, so we circle those.